everyone! So today I'm gonna be presenting my Rube Goldberg machine, and this setup is kind of a complicated setup, but here I'm gonna demonstrate how to use it. And my name is Jamila Santander, and this is my neuroscience project.
Now the setup.
So here for the setup, we have a cardboard box that I cut up, and the strings, dominoes, and this cup, and a pulley here. As you can see, I have a ramp and a balloon for the grand finale.
Now how it works.
So in here, it starts with a marble sitting on top of a spiral paper ramp. There is a wrapped around paper on the bottle, and once I release this ball, it rolls down a spiral and it picks up speed going onto the dominoes. So once the ball hits the dominoes, it's causing a chain reaction. Okay, so once that last domino hits the cup, and inside the cup there are strings attached, which is tied to a cardboard ramp that I cut up here. And as the cup gets heavier, this ramp itself moves up,
Holding the car.
once that ramp tilts, the car rolls down fast and smooth straight into the balloon, and that is the final action of the Rube Goldberg machine.
So now I'm gonna be showing you what simple machines that I used in my innovation. First thing we have here is a spiral ramp that is an inclined plane that lets the marble roll down smoothly. Next here we have the car and wheels that act as a wheel and axle, which reduces friction. For the third one we have the string and cup. This works like a pulley system pulling up the ramp. For the fourth one we have a ramp hinge that acts as a lever allowing it to tilt. And lastly, the dominoes create a simple chain reaction which transfers energy step by step. Now let's see what happens when we combine them. When the marble rolls, force and gravity makes it accelerate as it covers distance. You can see its speed increase with each turn on the spiral. The straight movement shows velocity, while the curved spiral path shows acceleration as it speeds up before impact. Now this is where it gets interesting. The car demonstrates all rotational motion, and its wheels spinning show torque, moment of inertia, and angular momentum, all in one quick roll down the ramp. Here's a quick replay on energy and motion. Real-life applications.
So in real life connections, this is actually applicable to like those machines that are those factory conveyor belts or vending machines, wherein all the motions are connected to one another, and by moving them, it completes a simple task like popping a balloon.
So now I'm gonna be explaining what worked, what I learned, and what failed as well. So what worked was, the whole machine actually worked in the end, but what I learned was you really need to make small adjustments that makes the machine flow more smoothly, and just a small movement like making the dominoes a bit closer or adding a bit more dominoes so that it's for sure going inside the cup made a big adjustment to how the video came out. Also, what failed was the first attempt I did was putting a bracelet string on the pulley, which made it not smooth out when the dominoes would go in. So the thing that I swapped it with was a thinner ribbon that made it slide perfectly when the pulley did do its job. And I learned that small movements, small adjustments, as well as positioning is really important into making sure your machine works, and also identifying those small details that could make it even better than how it already is. Reflection time. So honestly, building this Rube Goldberg machine was kind of a mix of fun and chaos. Some parts didn't even work at first, like for example, the ball not even making it to the dominoes, and like how it wouldn't go into the cup, on the timing, and how the car would sometimes slide the other way, and how the pulley sometimes didn't pull perfectly or smoothly. But I didn't expect it to actually teach me how motion and timing is really important for machines like this to work. How every machine around us is actually made of many different machines. For example, the machine I made earlier was a mix of pulley, wheel and axle. It had momentum and angular momentum and inertia, and it taught me a lot of things that I had to research, and also how like small things like a car is actually made up a lot of different things. Seeing how every small movement makes a difference or connects to the next made me realize how physics is everywhere around us. Just by opening a door, the door frame or the door handle. There's many different mechanics to it than we think. In the end, it was super fun to make, and I got to be creative, test things, and yeah, popping the balloon from all that machine work was pretty satisfying to watch. And thanks for watching, that's all.